Okay, 11.2 fundamental particles. This only started about more than 5 years ago lah. So earlier people fine. Except your new syllabus required slightly more lah.
Okay.
That's your syllabus. Right? Earlier syllabus mainly this part lah. Now you require to know all this lah. And a little bit of this lah. This part no need lah. This part. Okay, this one you can read during your free time lah. If you want to know the background of all that. Right? But not necessary lah. These are just extra info, that's all. Okay, fundamental particle, that's the size of your atom in cm, size of nucleus. Proton or neutron is about there, slightly smaller than 10 to the power minus 12. Remember this in cm. Quark is smaller still. Element, sometimes people call it elementary or fundamental particle. Subatomic particle are particles smaller than the atom. Particles that cannot be broken down into smaller pieces. That's so far the knowledge that we have it may change in future, but at the moment, we say that fundamental particle, that's the smallest we can see. It cannot be broken down into further. Neutron and proton are not elementary particle. Quarks, electron, and neutrinos are elementary particle. Particles and antiparticle, matter and antimatter. Each particle has an antiparticle. Right? Example, particle can be proton, neutron, electron, neutrino. Example, particle, electron, antiparticle is positron, positive electron. So not found in normal matter. Where do we start? Where do we found them? High energy collision experiment. I mean, it's a particle accelerator. Right? We accelerate particle to high speed and let them collide. Or interaction of cosmic ray with air particle. Cosmic ray are high speed charged particle from space. Right? Or we can only found antiparticle in radioactive decay. Matter and antimatter, if it's matter, proton, electron, antimatter will be antiproton. Then electron becomes positron. That's antimatter. Right? Example, matter is electron, negative charge. Antimatter is positron, positive electron, same mass as electron, same magnitude of charge. Right? Except it is positive, electron is negative, that's all. Pair production and annihilation. Proton and antiproton, when they collide, when they combine or collide with each other, we call annihilation. They disappear and give to gamma rays. Same with electron and positron. When they collide, they produce two gamma rays. When particle and antiparticle meet, they annihilate each other, releasing their combined mass as energy. Right? So the combined mass becomes energy of in the form of photon or electromagnetic radiation. Minimum gamma photon energy needed for pair production. You can also have two gamma combined to produce your antiparticle. Right? Minimum energy is 1.02 mega electron volt. Okay, this one we won't go over You got free time, you can read Okay. More important, right? Up, you can call it U. Quarks are fundamental particles that make up the subatomic particle such as proton and neutron. So you can find the quarks or antiparticle fundamental particle in proton and neutron. Proton and neutrons are in the category of particles called hadrons.
Okay.
Hadrons are defined as any particle made out of quarks. Fundamental means that quarks are not made out of any other particle, no others inside there. Another example is electron. Electron is also a fundamental particle. Quarks have never been observed on their own. They are either in pairs or groups of three. There are 6 we call flavors or types of quarks that exist. Up, U,
Okay.
C, top, T, down, D, strange, and bottom. Right? Top opposite is bottom lah. Jump, strange lah. Up will be down. Properties of quark.
Okay.
Charge of hadron is determined by the sum of the charge of the quarks. So if you have a hadron by a proton, you see the quarks inside there, and then you add up to get the charge. Each flavor of quark has a certain relative charge. Combination, each flavor have its own charge. All these on top there will have 2/3 E lah.
So why is it when they have the same? Why is it when they have the same charge, right? And like the same, they're not really the same particle, right?
They are different particle. We don't need to know further than that. We just need to know how to add them up and
Okay.
how they combine. So all this bottom one is minus 1/3 E lor. For example, a proton is made up of 2 up quark, 2 of this, and a down quark. And that one you have to memorize. And then you need to know how to add up to get your positive proton, positive E. Example, 2/3 up, 2 up, 2/3, 1 down, minus 1/3, so you get E. Equivalent antiparticle of the quark is antiquark. They are identical to quark, except that opposite in relative charge. Right, like this one, anti-up will be minus 2/3.
Okay.
Like here. Right?
Oh.
Put a stroke up there.
Okay.
Equivalent particle, you just memorize this one. That's all. And then remember, it's just opposite if it's anti. Right? Anti-up. Equivalent or anti-particle of a quark is anti-quark. These are identical to quarks except with positive relative charge. Right? This one, quark is 2/3 E, it's become negative. And then if it's down, it's minus 1/3, so you can plus. Each flavor of anti-quark has either, right, which is minus 2/3 or plus 1/3. You'll be expected to remember the charge of each quark. However, instead of memorizing the charges of anti-quark, just remember they are identical but opposite to in sign to the quark, that's all. So memorize the quark enough. Okay, how about this one? What's the answer? First thing, you have no choice. I have to work it out. That means you have to remember the charge. But Cambridge is more compassionate lah. Usually A and B only lah. But sometimes they are a bit tricky lah. May go to the end but they don't usually force you to do all of them lah.
C would give a charge of 0. And then T would give a charge of 0, and then D would give a charge of -1, right?
You have to add it up, lor.
Hmm. That's what I got, lah.
What is your
For
answer?
C. C and D. C would get 0, and
Okay,
then
A is 2/3, up is 2/3. Strange is -1/3, -1/3, so it's 0. Jump is 2/3 E. Down is -1/3 E, so you get 1. And C, top is 2/3 E. NT up -2/3 E, 0.
hmm.
NT up is minus E, -2/3 E, -2/3 E, 1/3 E. So answer is your B, lor. Can?
Oh,
We don't want 0, we don't want -1. We only want 1.
yeah, I didn't read the question properly. Sorry.
Fundamental particles, leptons. Right? This is electron.
Okay.
Leptons are group of fundamental particles. This means they are not made up of any other particles, no quarks inside.
Okay.
There are 6 leptons altogether. Muon and tau particles are very similar to electron, but with slightly larger mass. Right? Remember, if you want me to teach, the notes are all ready. But if you want me to answer question for you, you have to tell me earlier so that I prepare it and then don't waste time in the class searching for it.
Okay.
So if you want to fix a date where you want to have tuition, also better.
Hmm.
Electron, right? This electron, that's your muon, mu for muon, negative there, tau, negative there. Electron, muon, tau, particles all have the charge -E and a mass of 0.005 mu. This one is a bit larger, right? But about there. And for electron, you have electron neutrino. For muon, you have your muon neutrino. For tau, you have your tau neutrino. Right? So these are the 6 leptons.
Okay.
There are 3 flavors, types of neutrino, electron, muon, and tau. Right? That's what it means. Neutrinos are the most abundant leptons in the universe. They have no charge and negligible mass. Very small, very close to 0. Leptons interact with weak interaction, electromagnetic and gravitational forces. However, they do not interact with strong force. Strong force will be your nuclear force. Although quarks are fundamental particle too, they are not classed as leptons. Right? Quarks slightly bigger mass, so they are separate fundamental particle. They are not leptons. Leptons do not interact with strong force, while quarks do. What composition? This one you have to memorize. For proton is up, up, down. Neutron is up, down, down. Proton and neutrons are not fundamental particle. They are each made up of 3 quarks. Proton has 3 quarks. Neutron has 3 quarks. Proton is made up of 2 up and 2 down. Memorize. Neutrons are made up of 2 down and 1 up. Okay, try this one. This is a partial question. In the nucleus of iron, how many up quarks are there? No choice. So the question you have to calculate for each of them.
Okay. 82 quarks.
Answer?
82 quarks.
Up. How many? 82.
Oh, sorry, 82 up quarks. Yeah, up quarks.
Okay. Remember your proton is up, up, down. 26 proton, There's 26 up, 52, 26 down. Quartz composition of neutron is up, down, down. There are 30 neutrons. Right? This one subtract in iron. So it's 32 up. Right? 2 down times 30, 60 down. So it's 82 up. Okay, good. Yeah, fast.
Thank you.
Okay. Okay, hadrons, we can divide it into baryons and mesons. Right? What's the difference? Baryons got 3 quarks.
Okay.
Meson got 1 quark and 1 antiquark.
Okay.
All this memory work only lah. Can't actually help you to understand. It's just memory work and know how to apply.
All right.
A group of subatomic particles that make up of quarks. They are heavier than your electron. That's why they call hadrons. These are either baryon, 3 quarks, meson, 1 quark and 1 antiquark. Okay, quarks and electrons are regarded as fundamental particles. Pairs of quarks produce particles called mesons. Example, pi meson or pion. It's the letter pi lah. That's why it's 1 up, 1 down. They will probably ask you to find the electron configuration, the electron configuration, how to add up the electron charge there of the pion, of the pion. Okay, that's your up. You don't need to memorize that. Right? Know that this one is positively charged, this one is negatively charged. A lot of things can come out. Right? There's no restriction on them. Except you need to know how to know the charge and how to add them out.
Okay.
But all the symbols you don't need to know. Quarks never been discovered on their own, always in pairs or in groups of 3. Anti-hadrons, same memorize hadrons, then anti-hadron is just different. Right? It's anti-baryons will be 3 anti-quarks. Anti-meson is the same as meson. It's just a anti-quark and a quark. Right? Anti-meson.
Wait,
Yeah.
so anti-mesons and mesons are different?
Basically, they are
But
quite similar. You can see there. It's quark and anti-quark. Not much different.
okay.
Note, all baryons or mesons have integral whole number of charge. That's important. Whole number of charge. This means quarks in baryon are either all quarks or all antiquarks. Right? Baryon, there are 3 quarks, so it can either all be quarks or all antiquarks. Cannot be a mixture. Combination of quarks and antiquarks don't exist in baryon. Right? Example, you won't have this side. Anti-up, up and down. You don't have that. Antiparticle of meson is still a quark antiquark. The difference between quark becomes antiquark and vice versa. Okay, try this one.
Okay.
So you don't have to be frightened. You just need to know it's 2 positive electrons, that's all. So you just have to add up all this, eliminate what is not possible, and then no need to work it out.
I would say A.
Since it's a baryon, it's made up of 3 quarks. So C cannot be the answer. It's not 2 quarks, so this is a meson. Baryons are made out of 3 quarks and 3 antiquarks. Baryons are made out of 3 quarks and antibaryons are made out of 3 antiquarks. So we eliminate B. It's either A or D. We just work it out. Right? And know that these 2 positive electrons, adding up the quarks in A and D, right? That's minus 2E. So answer, you're right, A, good. How about this one? Circle all the anti-leptons in the following decay equation. Yeah, a bit more challenging lah.
Yeah. One.
Okay, this is your pion. It's a type of hadron because it's positive electron, positive charged electron, and it's made out of quarks. This means it's not fundamental particle and hence not a lepton. Muon plus is antiparticle of muon, right? And therefore anti-lepton.
Oh, so it's okay.
Muon neutrino is neutrino. Right? You want anti-lepton. Neutrino is a lepton. Muon neutrino is a lepton, not an anti-lepton, which would be an anti-muon neutrino. Right? That's the mu there. Mu is muon. Okay, so that's the answer. This one is more challenging. So I expect some to be like you have to think through or crack your head a bit.
Yeah.
Remember, quark combination is useful for exam. However, as long as you can remember the charges for each quark, it's possible to figure out the combination by making sure the combination of quarks add up to the charge of the particle. Okay. Quark composition, beta minus and beta plus. Right? For your beta decay happens via weak interaction. This is one of the 4 fundamental forces and is responsible for radioactive decay. Right? Weak interaction. Quark composition of beta minus, right? That's your neutron. Is a neutron, change of proton. That's your electron emitted. That's your anti-neutrino, electron anti-neutrino. Recall that beta minus is when a neutron turns into a proton, emitting an electron. That's your electron. That's the proton. So you should know up, down, down, up, up, down. So it's basically a down converted to an up.
Okay.
Beta plus the same, right? It's a proton changing a neutron, emitting a positron, and electron neutrino. Right? Memory work. So you can remember is proton is up, up, down. Neutron is up, down, down. So it's basically a up converting to a down. Okay, any comment?
How does the up quark turn into a down quark?
I don't know. I'm also
Okay.
asking like you also.
Uh, okay, it's okay then.
So far,
Apart from that,
so far I haven't
yeah,
found anything. Haven't found anything in the book yet. So I see
okay.
it's more about memory work lah. Because it doesn't make sense to me also. Equation beta minus is given that using quark model of beta decay, prove that the charge is conserved in this equation. Can you can I give you the answer?
Uh,
Neutron is down, down, up, no? Proton is up, up, down.
done. Okay. So that means
You show the left hand side equal to right hand side lah, the total charge,
hmm,
total electron charge.
so neutron is neutral lah, no charge. Proton is like 1e, then electron is negative 1e. So resultant is 0. Electron anti-neutrino is it's also 0 charge, I think. So it's not
You cannot use that
precisely
because you have to use the quark model. You have to calculate the
okay.
charge of left hand side of the
Okay.
equation. Can
Uh, Still doing. Uh, oh, yeah, can. Can. Hmm.
So you just have to show the charge is 0 on left hand side and right hand side. This one is 0 already because it's just opposite to each other.
Yeah.
Okay. The search continue lah. So we won't bother about all the history. Then let's try some of the question.
Okay.
Which of the following are baryons? Memory work only, nothing much you can teach you about.
Okay.
Okay, we have to stop in 10 minutes time. So I see you next week lah. After we stop.
Okay.
We won't
Okay.
carry anymore lah because we should finish already, more or less. Can?
Uh,
Remember, electron is your lepton.
yeah. No, so cannot. No. Okay.
Neutrino is also your lepton.
So I say D, is it D?
This is a
Okay.
anti-lepton. A,
Okay.
proton and neutron.
Okay.
How about this one? 2016 June 12 paper 1-2. Memory work, can work it out.
D.
Okay, good. How about this one?
A.
Okay, good. This one?
Uh, 2 up quarks, 1 down quark.
Okay. Donkey. No need to add up, right? You can memorize up, up, down.
Uh, C.
Okay, good. About this one?
Okay. B.
Okay, good. Memory work only, you can see that most of the questions, these are from
Yeah.
16 June, paper 1-2. Then this one is just basically just need to know how to write the configuration now. So you just, we have done that already so many times, so I think we won't bother lah. Just know how to do all that. How about anti-proton and anti-neutron
Oh,
as a quark composition?
antiproton is anti-up, anti-up, anti-down.
Okay, good. You got it.
And anti-neutron is anti-up, anti-down, anti-down.
Okay, good. Let me see any more question to ask you. If not, we'll call it a day. It was well to work out. Don't think we worry about this one. It's more or less the same thing.
Okay.
This is the same thing also. Try this one. A hadron has a charge of E, where E is an elementary charge. The hadron is composed of only 2 quarks. One of these quarks is a anti-down quark. By considering the charge state and explain the name of the flavor of the other quark.
Mm, yeah. Could it be a charm?
Okay, you are told it has a positive charge,
Yeah.
and then it's anti-down. Anti-down, down is minus 1/3, so it's plus 1/3 lor. So you need plus 2/3 E lor.
Oh,
Can
okay.
a down quark minus 1/3 E, the anti-down plus 1/3 E to obtain E. That's your reasoning lah. That's your reasoning part lah. Either way lah. Either one way of reasoning or the other way.
Okay.
Okay. Anything you want to ask? If not, we'll stop for today.
Uh, I thought like a charm and a top quark have the same charge, right? 203 E. What's this?
Yeah.
So why not the charm or top, but then the arc quark?
You are asked to identify the flavor, that's all. So charm could be right, but it's just by considering the charge state and explain the name of the flavor of the, you can call it upquart, you can call it a charm quart, but usually we choose the easiest one rather than choose a charm or the other one is top lah.
Okay, sure. I
These are
think
more
apart
unstable lah.
oh, all right. I think apart from that, no questions.
Okay,
Yeah.
we'll stop here lah. If there's no other question, let me
Thank
know
you.
when if you want the next class.
Okay.
So remember,
Thank you.
you have to tell me what you want me to do. If it's lecture, okay, I'm ready to teach you. But if it's answering question, you have to tell me what to do. So I do it first before I come to our class.
Okay.
Okay, okay, bye-bye. Have a good day.
Thank you, Mr. Koo. Bye bye.
Bye-bye.